which is 3n, 1, 2 here, right? And then where are these dots? Do you calculate this? No, you don't. These dots happen to be right there. How am I calculating this? I'm not calculating. How am I doing this so fast? Is the question now, isn't it? This is a little secret about the parabola. And let's...
You're just using the low power or the low number squares.
Oh, actually it's better than that. What?
There's a pattern?
Yeah, watch this, right? Think of it as a slope of a curve. That's 1. This is 3.
5.
How many of you knew this pattern already? Show hands. Good for you. You noticed something like this, right? And then guess what the next one will be? 7. Really? Okay, but that one is nice, right? What about this? Let's say g of s x, much more like what you did in the diagnostic tests, fake test, right? When you have something like this, then of course your vertex is, oh, it always comes in quarter when you complete the square, right? So this is, oh, let's make that plus, so negative, so I can recycle this space right here. 2.5 and 4.25, right? And let's plot that. 2.5, 4.25 is right there, right? Now, what is the pattern? Doesn't that get messed up? Well, there's a new pattern. It goes through these 2 points, and then 2 and 4. Guess what the next point is? 6. I mean, you don't really want to go that far, but hey, we could, because it only takes less than a second to put these things. So that let's do it here this way. 2, 4, down, down. My God, why didn't anybody tell you that before, right? For that reason, let's not recycle the rescale the axis if you can help it. This is better. Again, you can see the shape. Aren't they beautiful? But now my question is, why does it work? See, this is the question. When you have 1, 3, 5, dot, 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 2n minus 1, what does that add up to? What is the sum of this arithmetic series? Oh, you forgot, huh? Let's review. Let's review how to add this arithmetic series. All arithmetic series can be added up this way. You flip around. So this is 2n minus 3, and this is 2n minus 5, and dot, 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 and then 1, right? Then we add vertically. So you have 2 times s sub n. And this is, oh, 2n, 2n, 2. Oh my God, are they all 2n's? Yes. So how many such 2n's do we have? N of them. Divide both sides by 2. N squared, x squared, quadratic, hello. Oh my God, huh? That's why this pattern works. And you can prove that even number thing in a similar way. Okay. Having said that, well then. What makes you so sure that we can add equations vertically? I mean, we've been doing it since 6th grade, but did anybody justify that step? What makes you so sure we can do such a thing? Right. Yeah, I know. You have much to learn. Say, here's an equation. Okay, here's an equation. Let's see if we can add it vertically. If you add vertically, this becomes 5, this becomes 5, this becomes 10. Oh, still true, eh? That's why. Dang, huh? If you think about it, everything on this quantity is exactly the same as that. Everything here, oh, this is annoying. It's exactly the same as that. This. Like if you add those two, why shouldn't they be the same thing? Amazing, isn't it? Yeah, let's notice the pattern. I think you know this already, but hey, just to be sure, exponential and logarithm. So suppose we have coordinate system like that, and say we want to do 2 to the x, which is just 1, 2, 4, 8, isn't it? It doubles each side, and if you go to the left, it takes half, so asymptotically like this, right? This is the easiest pattern there is. And then, of course, this inverse function, let's do it with red, color, light. I mean, this is color. One good thing about this digital learning is you have very colorful notes, which is, of course, log 2x. And that's sideways, this way by 2, this way by 4, you know what I'm saying? And 8, and half, quarter, eighths. Huh, how about that? And then you can translate it to any other position, flip and stretch all you want. Good. Okay. Any questions so far? Okay, now, well then, let's talk about logarithmic properties of logarithm. Okay, what's the first one? Log some base u times v becomes what? Can somebody please use a microphones?
U plus log of v.
Yeah, very good, right? I mean, we all know this, right? After all, you have to use it, memorize it. Does anybody know how to prove it? You what? We have to do proof in this class? Only induction. Not this. You don't have to know how to prove this. But induction, yeah, you do. That's not until chapter 5. So when we get there, so chapter 5, that's approximately, like August? Oh, no, August. August is August right now. I mean, approximately October, late September. Yeah, I will let you know. So let's learn how to prove this. Okay, we let x to be log bu and we let y to be log bv. So these two things, you get it? Then now this value of log is the exponent, right? We know how to convert it into exponential form like this. Right? Tell me you know how to do this. Now, then I want to know what u times v is. Why the hell would I want to know what u times v is? What's my motivation? Because there's a uv here, you see. I want to know what that is before I can figure this thing out and prove it. So u times v, rule of exponent will tell you it is b to the x plus y, eh? And convert that back to logarithmic form. So therefore we have log b uv is equal to x plus y. Now all we have to do is remember what x plus y was. X plus y are these two things, eh? Substitute. So therefore now log b u times v is equal to log b u plus log bv. How about that? Huh? These things almost prove themselves now, don't they? Second property. Log b u over v. What does it become? Useless kids.
It becomes log
Too
v.
late. Too late. I wrote it down. You have to say it before I write it. I will let you prove that as an exercise on your own. Okay, it's almost the same thing. Third. Okay, have your microphone ready. Log b u to the m's power. It becomes what?
N
M
log
log
B of U.
Ah, see, this is so much better, more lively. It feels like class, right? Doesn't it? Okay, now let's prove that. Okay, like before, we let x to be this thing. Log is always log bu, and we don't have y. Now, then, by, of course, that. Now, I want to know what u to the m power is, since I have u to the m power here. You get it? So u to the m power, this one I'm going to take a little bit more time. Rule of exponent tells you this is it. And then this and this, I convert that into logarithmic form. So we have log b u to the m is equal to mx. You get it? And x is equal to that thingy. So substitute. So therefore, finally, is the class moving fast enough for you? You want me to speed up? I can go faster. Slow down a little. Sorry, I have to jam in so much information into this one session, so now I can't slow down. Okay, so perfectly all right speed then, huh? Okay, 4. Change of base formula. Most books don't think of this as a change of base, but hey, to me it is. Log some other base, e, let's say e. If this e, I mean, it could be any number, A, B, C. Oh, no, not B, B is here. A, B, C, E, F, G. But then, yeah, it may or may not be our exponential function E, but then why the hell not? This is the only place that we ever use change of base. And then we put U here and you put B here, right? That's change of base formula. Let's prove it. And most books don't have this proof for some reason. Okay, let's do it. So, once again, let x to be log bu, and that way b to the x is equal to u, and that same b to the x is equal to u. I want to take log e on both sides. See, we can take log on both sides. You know what I'm saying? You can do anything on both sides as long as you do it equally. Then that x come to the front. We just proved that in third property. And then divide by that thingy. So x is equal to log EU over log EB, hey? And then all you have to do is remember what x is and shove it back in here. So finale, log BU is equal to log EU over log EB, huh? All of the properties of logarithm has been proven. All of this is in the Dropbox note, and it'll be in your OneNote for a few days. So in case you're like falling behind writing things down, don't worry about it. Then hopefully I will be able to figure out how to post the recording. Okay, then. Now let's talk about parametric equations. X is equal to A cosine T, Y is equal to B. By looking at it, you know what it is, right? What is it? Oh no. And you know how to eliminate T and put it in a Cartesian form, XY relationship.
X squared plus Y squared.
No, not quite. Well, take out your calculators. The hell is wrong with my calculator? Oh yeah, there it is. Oh no, I didn't want to show you this cool stuff. Okay. I know, amazing, isn't it? I know, I amaze myself sometimes. Can your young eyes see the small screen? Yeah, okay. Yeah, if you have time seeing it, then let me know. My old eyes already are having a tough time. Oh, what I figured out in this distance learning is if you hook up your computer to a gigantic TV like I do, then you have a huge screen. At home, I have 50-inch screen. Yeah, it works out nicely. I mean, an old TV, leftover TV. Okay. Go to mode. Mode. So go to radian mode, and then yours is at a function like this, right? Instead of function, go to parametric mode and click enter. Wow. I'm gonna mute everybody. Okay. Now you're there. And then go to y is equal to, then this weird thing shows up. And I want you to enter this. You have done parametric graph before, x is right there, like that. You ready? And then window, let's start from 0. This is just 2 pi by default. -6 to +6, -4 to +4. It just looks pretty that way. Ready? Watch. Bang. Whoa! What is it? It is an ellipse. Y'all have it? Okay. How can we eliminate this parameter t and put it into the form that we are used to? Well, let's do that thing.
Sine squared x plus cosine squared x equals 1.
Oh yeah, huh? So it becomes this, and this thing becomes this, right? And then we square both sides. While we are at it, then we add vertically. Then it becomes this. And cosine squared plus sine squared, as he said, is 1. Now we know what it looks like, right? Then the question you have right now is, why the hell anybody want to do such a thing when you have a nice equation like this? You wonder about that? And answer is here. Think of this as a motion, space-time. This is space, xy coordinate, and time. You get it? Suppose this is some kind of satellite motion. If you have this, this thing only describes the orbit of the satellite. Most orbits are elliptical, you know that, right? Slightly elliptical, almost circular, but it's not. Okay, but that's useless information. Have you seen enough spy movies? You are trying to monitor some terrorist camp, and then a lot of people are in a situation room, and okay, satellite will be in position 3, 2, 1. We have visual, and then it's like picture shows up. Now confirming target, because there's a guy that you want to kill. Okay, target confirmed. Somebody, analyst will say target confirmed. Okay, authorizing drone strike now. And then one of the general will say, Mr. President, we need a decision. And then president will look at it and think about it for a second and say, do it. Okay, we have authorization, releasing the missile. Missile on the way. Impact until 3, 2, 1, boom. Target destroyed. Okay, good work, everybody. Remember these kind of movies? The key here is that you need to know which of your satellite will be in position to do that. And if you just have this kind of information, it's useless. It's just the orbit. This thing tells you where your satellite is at all times, and more importantly, where it's gonna be in the future. So you can do this kind of drone strike. So this gives you a whole lot more information. For example, remember this direction of the trace? Right, it was like that. This thing does not trace like that. Remember in chapter 9, direction, indicate the direction of the trace? Yeah. Now I have a question. Can somebody reverse the direction starting here and go this way? Now, of course, the easy way is to put negative t instead of t, but that's kind of going backward in time. That's cheating. No, without doing that, just manipulating the equation with positive t. Can you make it start here and go around this way? Feel free to jump in.
Y equals negative b sine t.
Oh my God, let's try that. So we just insert your negative sign, right? You see that? Boom. Oh my. And you feel it? Who am I kidding, right? Half of you are going, what? Wow, does he know? Who is that guy? We have a stiff competition. Okay, think about that until I go get another bottle of water. I'll be right back. Okay, I'm back. Actually, you didn't even notice I was gone because my camera is showing the ceiling, right? I keep forgetting because I can watch you, so I'm assuming you're watching me, but I know my camera is hello, high class. Okay, it's not like I don't want to show my face. In order to record, and in order to write on it, I have to put my Surface Pro tablet down, and then camera is pointing upwards, so it's like, yeah, whatever. Okay, those of you who cannot feel it, let's analyze it. Yes, that's how I pronounce analyze, because it's so anal. Okay, when t is equal to 0, x is a and y is 0, isn't it? So our coordinate is a0, which is right there. Well, in our case, 5, 0. When t is equal to pi over 2, x is 0 and y is b, 0b, up there. You get it? You see that motion? And when you put negative sign, then of course it will be 0, negative b. Huh. Okay, now, since now we have analyzed it, let's try to go back to feel it, because feeling it is the best. Cosine graph looks like this, doesn't it? So initially it's a decreasing function. Sine graph looks like this, right? So initially it's an increasing function. Now put those two together, and let's say we are starting right here at a0. X coordinate, x is decreasing, meaning x coordinate wants to move this way, and y is increasing, so y coordinate wants to move that way. So do you feel this kind of motion? Feel it? Ah. On your homework problem, you have to feel some of these things, you know what I'm saying? Okay. Yeah. Okay, let's learn how to do equation of a line. You remember forgetting equation of line from your vector chapter? Was it chapter, what was it? 6? Oh, whatever, I forget. Okay, equation of line. Let's go that way. Okay. Suppose our starting point is 3, 2, and our ending point is 5, 5. So we have 3, 2, and then we end up at 5, 5. And I want to put a line through this thing. Wait, am I be able to do this in one take? Oh my God, that was amazing. How did I know where that things? I sometimes amaze myself, I'm telling you. Okay, that was, how did I know to start here? I just eyeballed it, but wow, dang, okay. Now, how can we put parametric? I forgot, right? Yeah. Or that distance learning, you didn't really learn much. Do you at least remember Points law form? You want me to write down the formula for you?
Yes, I remember.
Okay, so delta x is equal to 2, delta y is equal to 3. So your slope really is delta y. I can't believe I'm writing this down, but right, something like that. So your Points law form looks like this: y minus 2 is equal to your slope, and then x minus 3a. Oh, this is a lot more important than you know. I'm gonna change it a little bit. Too much algebra? No? But do you remember this is your symmetric equation? Already? Oh, how about that, huh? Amazing, isn't it? Now, from here, we can figure out the parametric equation, and that is, see, x minus 3 over 2, we'll set that to t, and then y minus 2 over 3, we'll set that to t. After all, these two are equal. You know what I'm saying? Then, this thing should tell you x is equal to 3 plus 2t. This thing should tell you y is equal to 2 plus 3ta. Oh, there you go, your parametric equations. Wow, right? As if you're not amazed enough, let's just try to feel it, because that's too many steps. Let's feel it. How the hell do you feel it? Think about it. Think of it as a particle motion. So we want to start, this as our starting point, and move to 5, 5 in 1 second. Let's say delta t is 1 second. In 1 second, you want to start here and end up here. Okay, how can we achieve that? Well, we have to start somewhere, so let's write this, right? 32 is our starting coordinate. And 1 second later, we want both of these to be 5, 5. So we put 2 here, 3 here. Ah, there we go. Feel it yet? Whoa, how about that, huh? Okay. You guys taking physics?
Yes.
Good, good, good. Has your physics teacher taught you this yet?
Yeah. Yes.
That, right?
Hmm?
Let's think about it. This is really like a d is equal to RT, except, right? We are in, this is embarrassing. Let's erase that even. We're taking physics. Okay. So let's just put it into 3D vector equation. You see parallel? X naught instead of X naught, R naught plus your velocity times time. Eventually there will be, have you learned this yet? 1/2 AT squared. I mean,
It's okay. Sorry to stop here. Could you scroll a little bit below, please?
like that?
Like scroll down.
This way?
Yes.
That's not,
Mhm.
oh, okay. Oh, you're getting cut off. Okay.
Yeah.
But yeah, that's when we have acceleration, but without acceleration, this is just constant motion. Let's try to get these. We first need to get v. V meaning velocity vector, and we'll say we get there in 1 second. And that velocity, according to Miss Slattery last year, this is v, isn't it? And that v, of course, is 2, 3. You know what I'm saying? Change of x, change of y. We shove that in. So initial coordinate is 3, 2 plus our v 2, 3 t. And this thing becomes 3 plus 2t and 2 plus 3t according to our vector arithmetics. And then lo and behold, this is your x, this is your y. Ah, amazing. Okay, maybe you don't have to know this just yet, but this, can we at least feel it? Yeah, let's try to feel. Feeling it is infinitely better than analyzing it, I'm telling you. Okay. Okay. We have to show our work, okay? We analyze, we have to. But we already know we felt the answer. We have it deep down. We just need to justify our feelings. That's when we analyze, not the other way around, okay? Oh, that's profound truth right there. Okay, now, what time does this period end? 45. Wait a minute. 55 to 45. Oh, almost. Okay. As a fun exercise, I want you to try this. Go back. Y is equal to. Just get rid of y and just type in t. And let's see what, just for fun, go to Windows and start t from like -7. And then see what happens. Ready? Bang. Sideways cosine. You can do about anything with parametric mode. It gives you that freedom to describe anything. Any questions? Okay, I'm gonna stop recording.